In this video, I'm going to talk about a really important feature of PSpice called analog behavior modeling. PSpice mostly deals with two types of modeling called structure modeling and behavior modeling. In structure modeling, we build a desired circuit using different components like resistors, capacitors, diodes, etc. and we get the desired results. While in behavior modeling, we use different functional blocks in order to model our circuit. The focus is mostly on the input and output relationships of that block. PSpice uses the dependent sources like voltage control voltage source, current control current source, voltage control current source, and current control voltage source in a library called analog library. Now in order to see that, you have to go to the library, go to the analog library, and these dependent sources are saved by a symbol of E, F, G, and H. However, for more complex type of modeling, PSpice uses a special library called analog behavior modeling library, where you can find different types of blocks available, and you can use those blocks in your circuit for desired operation. In this circuit, we have used a voltage control voltage source as an amplifier. Now in order to do that, you need to go to PSpice, go to analog library, pick up voltage control voltage source block, put it in a circuit together, double click on it, go to gain, set the gain to any desired value that you want, apply an input voltage, set the output, run it, check the input and the output. We can see that the input voltage is amplified 10 times depending upon the gain that was set to that block. We can also model the JFET amplifier, and we know that the equation of JFET amplifier drain current is given by this equation. Now the maximum possible drain to source current is 12 milliampere, VGS off is minus 3 volts, so you can put these values in this equation and the final equation will become like this. Now in order to model this, you need to go to the ABM library again, pick up the G value block, put it in a circuit together like this, double click on it, go to expression and type the desired drain current equation. Apply an input voltage, set the output, run the circuit, check the input and the output voltages. We can see that the output voltage is amplified. So JFET block is acting like an amplifier, a voltage amplifier. You can also even model a low pass filter using ABM libraries. For this purpose, you need to pick an E frequency block in the ABM library, pick up the E frequency block in the ABM library, put it in a circuit together like this, double click on that block, go to table and set the frequency, magnitude and phase. Take as many points as you want. I have taken 4 points. Run the circuit. Check the output in dB. We can see that this block is acting like a low pass filter. You can also check the phase. The phase is given like this. You can take much more points in order to smoothen this response of low pass filter. The ABM library have another block of differentiator where you can find the differentiation of the input signal that is applied to that block. In order to do that, go to the ABM library again, pick up the differentiator block, put it in a circuit, set the gain to any desired value that you want, run the circuit. We are taking a linearly increasing input signal, and we know that if we take the derivative of this linearly increasing signal, we will get a straight line, and here is the result, straight line of 1 volt. If you increase the gain of this differentiator, the output voltage will be increased with that value of gain. You can even model an integrator using ABM library. Now we know that mostly we use integrators by using an op-amp, by connecting a capacitor and feedback and resistor at the input. But here the ABM library have made the job really easy for us. Go to the ABM library, pick up the integrator, put it in a circuit like this, set the gain to any desired value, run the circuit. The input is a square wave of 5 volt. And the output is a triangular wave. This proves the fact that this block is acting like an integrator that can be easily used in any circuit without going into the complexity of using an op-amp and all the other components. Now we can also model a rectifier using ABM, which is really a basic part of any circuit, and we know that how a rectifier performs its operation. If we can see the curve, the output that we get from a rectifier, we can notice that all the rectifier is doing is it is calculating the absolute value of the input AC signal. All the signal that is coming in to the rectifier, it is converted into a positive value. In order to do that, go to the ABM library, select the E value block, put it in a circuit like this, double click on it, go to expression and type the absolute ABS with the voltage that is associated with that block. Run the circuit. Check the input. And the output. So in this case we have modeled a rectifier using a single block rather than using 4 diodes and components that are associated with a common rectifier.